This is Unit 2, Dilations, Similarity, and Introducing Slope. This is Lesson 12, Using Equations for Lines. So in this lesson, we're actually going to use equations to look at some lines. This is activity number 1, missing center. And what they really mean by this is missing the center of dilation, not the center between these 2 points. So where is the center of dilation? Well, if you're taking image A and sending it to image B, so where's the center of dilation? So if you're moving from A to B, that's along a straight line. The center of dilation is going to be along that same straight line. The scale factor is 2. So this is going to be the distance that's doubled. So you have to move back that same distance along a straight line. And so the center of dilation is going to be about right here. So there's the line that A moves along to get to B. Center of dilation is about right here. And the midpoint between the center of dilation and B is going to be A, because that's halfway. So this is 1 time as far, and it's that same distance to get to B, so that's 2 times as far from C than A is from C. So B is 2 times as far from C than A. A is 1 times, B is 2 times. I think I show that. Yeah, A is 1 time from C, it's 1 unit, and B is 2 times from C, so that's 2 units. So now what if you take this? Now this is not in part of the activity, but I want to ask the question, what if you were sending B, image B to A with a scale factor of 2? It's the same idea. The center of dilation is going to be along this line, but now the center of dilation is going to be over here, because this becomes 1 times, or 1 unit, and this becomes 2 units. Because the scale factor is greater than 1, you're going to move away from the center of dilation. So down here, the scale factor is greater than 1, so you're going to move away from the center of dilation towards B. In this case, the scale factor is greater than 1, so you're going to move away from the center of dilation towards A. So the center of dilation has to be on this line, but it has to be back here. So it's going to be about right here. We're going to call that D. So that's the center of dilation, and A is 2 times as far from D than B is from D. Now what if we flip it around? Send A to B with a scale factor of 1/2. In this case, since the scale factor is a fraction, it's less than 1, then A is going to move towards the center of dilation. So it's going to move in this direction towards the center of dilation. So the center of dilation is still going to be D, but A is going to move back to B. So this distance from D to B is half the distance from D to A. So if the scale factor is a fraction, you move towards the center of dilation. If the scale factor is greater than 1, you move away from the center of dilation. So one last thing we can look at over here. Send B to A. So send this image B to A with a scale factor of 1/2. And so once again, because that scale factor is a fraction less than 1, you're going to move towards the center of dilation. So from B to A in this direction, so the center of dilation actually is going to be the same. It's going to be right here. So you're going to move from B to A. So this length from the center of dilation to A is half the length from the center of dilation to B. So now you've used a scale factor of 1/2 and move this back. Okay, that's activity 1.